In the last unit, we looked at how to create a basic floor element in Revit. In this unit, I want to show you how to take that basic floor element and start adding, let's say for example, drainage points to it. So we're going to learn how to slope the floor and also slope portions of the floor to create drainage points. So if I switch to a 3D view, just to show you guys, all I have to start with are just 4 walls. I'm going to create a simple floor element at first floor level. So this is really just a quick recap of what we did in the previous unit. So I'm at the first floor level, so that's where the floor is going to be created. So remember, it's the architecture menu, floor architectural. Remember that sketch mode, we were introduced to that in the previous unit. So green tick, red cross signifies you're in sketch mode. Revit is now expecting us to define or sketch out the boundary for our floor element. In this case, I want the boundary to follow the perimeter of the building, so I can use the pick walls tool. So when that's selected, I'm going to untick extend into wall core. Hover over one of your walls and Revit will detect it. Remember, if you've drawn your walls as a chain with that pick walls tool selected, if I hover over the first one, a single tap of the tab key will find the chain of walls. Now I can left click on my mouse to actually place those boundary lines. I'm going to work with the default floor type I've got selected here, so I'll leave that as it is. So I've got my boundary, got my floor type. All I need to do now is hit the green tick to go ahead and create that floor. Floor's created. I'll just switch to a 3D view just to double check, and there it is at level 1, which is my first floor. So now we've got a basic Revit floor element. The next step is to use shape editing tools to start adding slopes to that floor. So I'm going to switch back to my level 1 floor plan. Just going to go ahead and select the element we've just created. Once that's selected, if we look up on the ribbon, you'll see we've got modify floors as an option. I've got a panel there called shape editing with a number of different tools on it. We can, to this element or to this surface, we can add a point. That's what we're going to do in a minute to form our drainage point. We can add split lines which allow us to cordon off or isolate a portion of the surface, so we can dish that down locally, and I'll show you how to do that also. There is also the option to pick supports. So if, for example, you had a structural beam running under this floor at a lower level, we could use that tool to select the beam, and Revit would then dish or slope this floor accordingly. It would basically form a crease along a line which coincides with the center line of the beam, so we can use the beam as support for this floor. But for now, I'm going to start with just adding a simple point to the surface, the top surface of our floor element. So I'm going to select add point. Just before I do that, I want to mention these options on the options bar. So we've got elevation, currently set at 0. That refers to the height of the point that we want to add. So at the moment it's set to 0. So if we add a point on here, it's basically going to coincide with the surface itself, so it'll have no effect whatsoever. We need to offset that point either below or above the surface of the floor to have any effect at all. And we've also got the option to make that height either relative to the top surface of the floor element, which it is at the moment with a tick box on, or we can untick that, which makes this height an absolute height, if you like, a Z coordinate in our project. So you know the heights and the elevations we've set for our levels, it would be more akin to those heights. So again, if you know an exact height you need a drainage point to be, you could turn off the relative option there and type that height in. For this example, I'm going to leave this set to relative. So I want to form a drainage point 100 mil down below the top surface of the floor. So I need to put a negative value in here, minus 100. And I can go ahead now and click to add my point. You'll notice as soon as I do so, Revit triangulates the top surface of the floor element. So if I switch to a 3D view, you can actually see how the surface of the floor itself has been triangulated to allow it to slope down in 4 directions to that point in the middle, which is 100 mil below the original top surface before we triangulated it. Just going to very quickly add a section line through the center of our model. There is a dedicated unit coming up later in the course on creating sections and exactly how to manipulate those, so don't worry about how to do that at this stage. Just want to use a section to show you guys through the model. Just lower that view scale down so you can see that the floor does actually dish down to that low point of 100 mil down below the surface. People normally make the observation at this point the whole floor has been sloped down, and in reality you would probably only slope down the top layer. So for example, if we had a screed up near the top surface of the floor construction, then it would be the screed itself that would taper. The rest of these layers would remain consistent and they would be horizontal. So as we've created at the moment, it's probably not accurate to what you'd actually do on site. That's not a problem. We can actually set one of the layers in our floor type to have a variable thickness, and if we do so, that slope will be taken up just by that layer only, and I'll show you how to do that later on in this unit. Very rarely would the whole of the first floor be sloped down to a drainage point as we've just created here. More realistically, just a portion of the floor, let's say a walk-in shower room in the top right hand corner of the plan, would be sloped down to a drainage point or a gully, let's say in the corner. The rest of the floor would be horizontal. So let's look at how we do that now. So first of all, I'm going to select the floor. I'm going to reset the shape, so take off the shape editing elements, puts it back to how we first created it. Now I'm going to add split lines, so add split line, and I'm going to use the split lines to cordon off the area that we want to slope. And there we have it. So it's a separate part of the surface. So now if I add my point, remember, set the elevation of the height of that point relative to the top surface if you have that tick box left on. So I want my drainage point to be 50 mil below the surface of the floor, and I'll have it up near the corner of the shower room. And you can see now, rather than Revit triangulating the whole floor, it is just triangulating locally within the boundary of the split lines that we have added. Now I mentioned before about variable thickness layers. So if we go back to the previous example where we added a single point at the center of our floor, I've set that point minus 90 mil down just to make the slope a little bit steeper so it's easier to see what's happening. If I switch back to that section view, notice that the whole floor slopes down, so all the layers stay parallel to each other. So the bottom of the floor, the underside of it, is sloped as well. As we discussed previously, in most cases that's probably not what you actually want to happen. You'd want the vast majority of these layers to be horizontal and parallel, and then one of the layers, typically screed or maybe an insulation layer, to actually taper to make the top sloped surface. I'm going to show you how to do that now. So if I select the floor, we need to go into the floor type, the type properties. So if I edit type, and we need to drill down into the floor structure. So if I hit the edit button there, let's just widen this panel so we can clearly see all the information. One of the columns towards the end, or the end column in fact, is called variable, and it's simply a tick box, and it's up to you which of these layers that you specify to be variable. The rule is though that only one of them can be, because if you think about it, if you had more than one layer to be variable, how would Revit know how much to taper each of those by? So let's have a look down and choose, let's say, concrete masonry floor, just for the sake of example. It's 100 mil thick. Let's make that the one that can vary its thickness. Now it is important when choosing which layer to be variable that the layer you choose has a thickness greater than the offset by which you've set the point lower than the top surface. I'll try and clarify what I mean by that. Let's say we've set our point 150 mil down from the top surface of the floor element. In this case, the layer that we're making variable is only 100 mil thick, so it's not thick enough to actually take up all of the difference of the height of the point that we've added. In my example, I've set the point 90 mil down, so we've still got 10 mil spare. So at its thinnest point, this layer will be only 10 mil thick. So let's go ahead and leave that as the variable layer. OK that. OK that. And now hopefully you can see it is in fact this layer, if you look closely, the second one up, that actually tapers. So the underside is horizontal. This is the layer that we said was going to be variable, and you can see it does in fact taper down, right down to 10 mil thick, and all the other layers above it remain parallel but are also sloped. So in reality, I would suggest for our walk-in shower room, we would set a screed layer at the top. We'd probably have maybe a vinyl layer for the floor finish. Then we'd have a screed layer up here which would be variable. That would form the tapered layer, and then the rest of them would obviously be horizontal beneath there. I did do this previously in the unit, but just to recap, if you get into a little bit of a tangle with all these shape editing tools, and it's quite easy to do so when you start adding a number of split lines and points, you can actually get to a scenario where the surface is sort of totally messed up and it's easier to start again rather than trying to unpick it. If we just select the floor element on the ribbon there, we do have the option to reset shape. Simply click on that and it takes all the shape editing elements off there that you might have put on, and you're back to a basic floor element. And that completes this unit. To get the most out of this training material, please take the complete course online at bimscape.com. Here you will find a complete learning management system that allows you to work through the course at your own pace. Comprehensive written tutorials provide additional information to that found in the training videos. Mark each unit as complete as you finish it and move on to the next. At any point you can return to any of the units you have previously completed to go over the material again. If you'd like to take this course online, please visit www.bimscape.com/Revit for details.